let's dive in. We're talking Venus today. This planet is like Earth's twin, but instead of oceans and mountains, it's got this crazy hot surface and an atmosphere. Well, let's say it's not exactly breathable.
It's definitely a wild one. So close to us, but took such a different path. A real head-scratcher.
You've given me a ton of research and articles, so let's break it all down. We're going to look at Venus's crazy atmosphere, those wild cloud formations, even touch on the possibility of life.
Keep the big picture in mind as we go. What can Venus teach us about our own planet?
Okay, let's unpack this. Venus's atmosphere, brutal, 450 degrees Celsius. 860 Fahrenheit. Pressure's 92 times Earth's. You wouldn't last long there.
It's a huge challenge to explore. Electronics fry, materials corrode. Imagine building a submarine for a volcano, that's what it's like.
How do scientists even study it then? You can't just send a rover down, right?
Had to get creative. They built special labs on Earth just to test if our tech can survive there.
That's wild. What do they do in those labs?
All sorts of things. Develop these techniques using lasers and light to figure out what the surface is made of from afar. And they have these huge chambers, like massive, that can mimic Venus's heat and that corrosive atmosphere to test spacecraft parts. See if they can hold up.
Right, so you don't want your billion-dollar mission melting on arrival.
Exactly. And these tests are helping us understand why some missions, like those Pioneer Venus probes, ran into trouble. Remember that 12.5-kilometer anomaly thing?
I read about that. Remind me what happened.
All 4 probes, every single one, started glitching out electrically about 12.5 kilometers above the surface, losing data left and right. Scientists think it might be something in the atmosphere messing with the electronics.
Like an electrical storm or something.
Maybe, but we're not sure. Could be electrical discharges or some crazy chemical reactions. That's why those test chambers are so important. Gotta figure out how Venus messes with our tech so we can design future missions that can survive.
So surface exploration is a nightmare. What about those clouds, the famous Venusian clouds, what we learned about them?
Well, data from the Venus Express mission has given us some fascinating insights. The cloud tops at the equator, they stay at a pretty constant altitude, but towards the poles, they actually dip lower, like they're slumping.
Why would that be? Does Venus have weather patterns like Earth?
It does, but they're way more extreme. And different forces are at play. Studying these cloud behaviors can help us crack the code on how Venus's atmosphere works, which is a big piece of the puzzle, figuring out why it became so different from Earth.
Speaking of different, that phosphine discovery a few years back, that was a bombshell. That's what got everyone talking about life on Venus, didn't it?
It sure did. Phosphine is a gas that here on Earth is basically a sign of life. When scientists found signs of it in Venus's atmosphere using telescopes, it was huge.
So for the non-chemists out there, like me, what is phosphine exactly? And why is it such a big deal?
It's actually pretty nasty stuff. Stinky, poisonous. But here's the thing. On Earth, it's pretty much always made by living things. Microbes that live without oxygen,
So finding it on Venus means, are there microbes floating around in those clouds?
That is the million-dollar question. The scientists who found it really did their homework, ruled out all the usual suspects. Volcanoes, lightning, even meteorites. Nothing could explain that amount of phosphine.
So now they're thinking, is there alien life right next door?
Too early to say for sure, but the possibility is exciting, right? Researchers are now working on confirming the original detection, trying to map where this phosphine is coming from, looking for clues that might point to life, like changes in the signal, maybe daily, maybe seasonal, who knows?
It's wild to think this planet, which seems so hostile, might actually have life up in those clouds. Really changes how you think about where life might exist out there in the universe.
It really does. And that's just one reason why Venus is so fascinating. Scorching hellscape. Yeah, but it holds these lessons about the boundaries of habitability, how planets change over time. It's incredible.
This is already getting pretty deep, and we've just scratched the surface. What else is coming up in this deep dive?
We've got a lot to cover still. We're going to talk about how Venus rotates crazy slow, and how its atmosphere actually pushes back against the sun's gravity. Then we'll delve into those ancient oceans on Venus and how that might hold clues to the future of our own planet.
This is incredible. I'm hooked already.
Awesome. Let's keep going. We've got a lot more to uncover about Venus. So before, we were talking about how Venus's atmosphere can actually push back against the sun's gravity.
Yeah, pretty wild stuff.
It shows just how powerful those atmospheric forces can be, especially with such a thick atmosphere like Venus has. And it plays a huge part in why Venus spins so incredibly slowly.
Right, we were just getting to that. Venus is the only planet in our solar system that spins clockwise. And a day on Venus, it's actually all longer than a year there.
That's right. A birthday every sunrise, can you imagine? Venus rotates so slowly that the sun would actually rise in the west and set in the east. And it takes, get this, 243 Earth days for one rotation, but only 225 Earth days to orbit the sun.
So it's like the sun is this giant cosmic brake, slowing Venus down over time.
Great analogy. Over billions of years, the sun's gravity has been pulling on Venus, creating this friction, gradually slowing it down. We call it tidal locking, and it's the same reason we always see the same side of the moon.
Venus isn't totally tidally locked though, right? It still spins, just super slow.
Exactly, and that's where that thick atmosphere comes in. The sun's heat creates these crazy atmospheric tides on Venus, like ocean tides, but made of air. And these tides actually push back against the sun's pull, stopping Venus from becoming completely locked.
A cosmic tug-of-war with Venus stuck in the middle.
That's it. And studying this interaction can help us understand these processes on other planets, especially those hot Jupiter planets that orbit super close to their stars and experience even stronger tidal forces.
So Venus is like a real-life lab for understanding extreme planetary environments.
It really is. Now, speaking of extreme, let's talk geology. We can't exactly send geologists down there, but what have we learned about the surface from orbit?
I'm picturing volcanoes, lava flows, maybe some massive craters. Am I close?
You're on the right track. Missions like Magellan, using radar to see through those thick clouds, have shown us a world shaped by volcanic activity.
Like Hawaii, but on a planetary scale.
More like Hawaii on steroids. Venus is covered in thousands of volcanoes. Some are huge, like mountains that make ours look tiny. And there are these plains of solidified lava stretching for hundreds of kilometers. That's evidence of massive volcanic eruptions in the past.
Wow, intense. But here's a question. If Venus is so volcanically active, shouldn't it be covered in craters from asteroid impacts too?
You'd think so, right? But the surface is surprisingly young, geologically speaking, and that's made scientists think that Venus doesn't have plate tectonics like Earth.
Wait, hold on. What's plate tectonics again?
It's what makes Earth's continents move around. Imagine a giant jigsaw puzzle where the pieces are always shifting and bumping into each other. This movement releases heat from inside the Earth and creates mountains, earthquakes, volcanoes, all that.
Okay, so Venus doesn't have that. What happens instead?
Without plate tectonics to release that heat gradually, Venus builds up internal pressure like a pressure cooker, and every few 100 million years, scientists think, boom, that pressure is released in a massive planet-wide volcanic event.
So instead of those slow and steady changes like we have,
Yeah.
Venus has these dramatic, planet-wide volcanic makeovers. That would explain the young surface.
Exactly. It's like the whole surface gets repaved with lava every few 100 million years, wipes out those old craters, and creates a fresh new landscape.
Wow, that's mind-blowing. Could one of those upheavals be happening right now?
Possibly. There are missions in the works that will help us figure that out. NASA's Veritas mission, it's going to launch sometime in the next decade, and it'll use this advanced radar to map the surface in even more detail so scientists can study those volcanic features up close, even from afar.
Can't wait to see what they find. But before we move on, what about those rumors of ancient oceans on Venus? It seems like the last place you'd expect to find water.
Yeah, it does seem unlikely with how hot and dry it is today. But there are clues that Venus might have been a very different place billions of years ago.
Intriguing. What kind of clues are we talking about?
One clue is in the atmosphere. It's super rich in the special type of hydrogen called deuterium. Think of it like a water fingerprint. Over time, the sun's radiation can break down water molecules in the atmosphere, and regular hydrogen escapes into space easier than deuterium. So the high amount of deuterium on Venus suggests it may have had a lot more water in the past.
Where did it all go? Just evaporated away into space?
That's the leading theory. Scientists think Venus might have experienced this runaway greenhouse effect. Temperatures rose, more water evaporated into the atmosphere, trapping even more heat, and it just spirals out of control. Eventually, all that water boiled away, leaving Venus the scorching desert we see today.
That's kind of a scary thought. Shows how fragile a planet's climate can be. But it also makes you wonder, if Venus did have oceans, could there have been life there?
Now that's a question that has puzzled scientists for decades. It's definitely possible, but incredibly hard to prove. We would need to find solid evidence of past life, like fossils of tiny organisms. But that's a huge challenge with those extreme conditions and the fact that the surface has been reshaped by those massive volcanic events.
So it's like a cosmic cold case.
You could say that, but it's a case worth investigating. Who knows, maybe those future missions will find clues to a wetter, maybe even habitable past.
So we've talked about volcanoes, possible ancient oceans, even life in the clouds. It's amazing what we can learn from afar. But what are the biggest challenges of actually sending a spacecraft to this extreme world?
Exploring Venus is no easy feat. It's a huge challenge for engineering and a real testament to human ingenuity. Those early missions, like the Soviet Venera probes, were pioneers in Venus exploration, but they faced some incredible obstacles.
Weren't those the probes that landed on the surface and sent back those first pictures?
They were. They endured that intense heat and pressure, sent back all this amazing data about the atmosphere, even captured those first images from the surface. But they didn't last long.
I imagine they got fried pretty quickly.
Unfortunately, yes. The extreme conditions just overwhelmed their electronics and systems. But each mission, even the ones that didn't go perfectly, taught us valuable lessons about how to design spacecraft tough enough to withstand that Venusian environment.
And that led to missions like Magellan, which mapped the surface in such incredible detail using radar.
Exactly. Magellan's data revolutionized our understanding of Venus's geology. It showed us a world far more dynamic and complex than we thought, and it paved the way for future missions, like the European Space Agency's Venus Express and Japan's Akatsuki, which are still studying Venus's atmosphere and weather patterns today.
It's amazing how far we've come in exploring Venus. And with all these new missions being planned, it feels like we're entering a whole new era of discovery.
You're absolutely right. NASA's Da Vinci Plus and Veritas missions, those are launching in the next few years, are going to completely change our understanding of Venus's atmosphere, surface, and evolution. And the European Space Agency's got their own mission planned, envisioned to study the geology and search for signs of past water.
So much exciting science on the horizon. I can't wait to see what we uncover next.
Me neither. We've just scratched the surface of what makes Venus so fascinating. But speaking of scratching the surface, there's one topic we haven't really dived into yet: the search for life. That deserves its own conversation.
Right. We've danced around it, but let's really get into the details. What's the latest in the hunt for life on Venus? What are the possibilities, the evidence we're looking for?
Those are the questions we'll be exploring in the final part of our Venus deep dive. We'll unravel those mysteries and think about what it would mean to find life on our closest planetary neighbor.
It's going to be an exciting ride. All right, we're back. Final part of our Venus deep dive. We've covered a lot of ground in the scorching surface, that crazy atmosphere, even those possible ancient oceans. But now, the big question, the one everyone wants to know. Could there be life on Venus?
A question that's fascinated us for, well, forever. And lately, it's not just science fiction anymore, it's a real scientific possibility.
We've hinted at it, but let's dive in. That phosphine discovery a few years back, that was a game changer, right?
Oh, absolutely. Finding phosphine in the atmosphere, that changed everything. That gas is so rare naturally, and on Earth, it's almost always a sign of life. Microbes, the kind that thrive without oxygen.
So finding it on Venus, it was like a giant, hey, look over here, sign.
Exactly. And it wasn't just a tiny bit either, it was a lot of phosphine. Way more than volcanoes or lightning or any of that could explain.
So they basically went through every non-biological explanation, checked it off the list, and nothing fit.
They were thorough, I'll give them that. Ruled out everything they could think of. And that's what makes the idea of life so exciting, isn't it?
It's like a detective story. And all the clues point to one thing: alien microbes.
A cosmic mystery. And the investigation is still going. Scientists are trying to confirm that original detection, map out where that phosphine is coming from, looking for any patterns, anything that could say this is biological.
So it's not just proving it's there, it's figuring out what it means.
Exactly. Is this really life, or is there something weird happening on Venus? Some chemistry we don't even know about yet. That's what we need to find out.
Let's say it is life. What would that even look like? How could anything survive in those Venusian clouds? It's brutal up there.
Well, we know about extremophiles here on Earth, these tough little creatures that live in boiling hot springs, deep sea vents, places like that. So maybe Venusian life, it's some kind of microscopic bacteria, archaea, something like that.
Tiny little guys clinging to life in the clouds.
But they'd have to be super resilient, able to handle those sulfuric acid droplets, the intense pressure, very little water. Not an easy place to live.
Sounds pretty hardcore. Any ideas on how they might do it?
There are some theories. Some scientists think maybe these microbes, they cycle through different layers of the atmosphere, ride those updrafts and downdrafts to find better conditions, you know?
So like a microbial roller coaster, dodging the worst of it.
That's the idea. Others think maybe they live inside these protected droplets of water or sulfuric acid even. like little self-contained ecosystems in the clouds.
Make microscopic snow globes full of life. Amazing.
It is fascinating to think about. We don't have proof yet, not for sure, but it's intriguing enough to keep looking, that's for sure.
That's where those new missions like Da Vinci I plus Psi come in, going right through the atmosphere, analyzing everything, looking for clues.
The Vinci I plus Psi, it's got all these instruments that are going to give us this incredible look at the chemistry up there, help us understand those conditions, see if they could support life.
And maybe, just maybe, find what they call biosignatures, signs that something's alive.
Now that would be a huge discovery. Life found on Venus. Can you imagine the headlines?
It would change everything we know about life beyond Earth.
It would. But even if Da Vinci Plus doesn't find absolute proof, it'll still give us so much data, help us understand Venus better, whether it could support life or not.
That's science, right? Always exploring, discovering, learning more.
Every mission, every observation, every piece of data, it gets us closer to understanding how our solar system works, all the wonders it holds.
This deep dive into Venus has been quite a journey. We've learned so much about this mysterious world, the surface, those clouds, everything.
We've seen the challenges of getting there and the successes of those missions that have braved those challenges and shown us what Venus is all about.
And yeah, the question of life, it's still out there, but it's a question that keeps us curious, keeps us pushing the boundaries of science.
So to wrap this up, I think it's important to remember how much we don't know. There are still so many mysteries, so many questions to answer.
That's what makes it exciting. It means there's still so much to discover out there right here in our own little corner of the universe.
Absolutely. And that's a good thing. Lots of wonder left to experience.
So to our listener, keep exploring, keep asking those questions, keep looking up. You never know what's out there. What amazing discovery might be just around the corner.
Maybe someday we'll be talking about life on Venus. Not as a possibility, but as a fact. Who knows?
Until then, keep those imaginations going, never stop exploring. Thanks for joining us on this deep dive into Venus. It's been a blast.